questions, just type it in the chat or unmute yourself and ask a question. Okay. All right, so we're going to go over this dry mix stuff. We're going to look at how to graph bar graphs and line graphs really quickly. And then we're going to do two together. We're going to do A and B together. And then C and D you're going to do on your own. Okay, and all these graphs you can do on a separate sheet of paper. You don't need to do it on here. You just need to eventually take a picture of it and attach it to the assignment. Okay, tomorrow we'll go over the quiz, and we also will go over how to graph in using Google Sheets. Okay, so we'll look at graphing in Google Sheets too. So we'll probably actually do like these same graphs, but just in Google Sheets. Okay, and I'll go over instructions on how to do that. Okay. Okay, so how to graph using dry mix. So dry mix really applies to mostly really just, there's three types of graphs we're going to look at. We're going to look at bar graphs, line graphs. The other type of graphs that we're not going to look at today, but that are popular, are pie or circle graphs. Okay, we're not going to do that today. All right. We can talk about that another time. Those are a little more tricky to do. But bar graphs and line graphs are very similar to one another, and that's what we're going to focus on today. And when we use bar and line graphs, we follow this little acronym here called dry mix. Okay. And it helps us to remember what variables are plotted on which axes on the graph. Okay, so dry mix stands for D is dependent variable. It's the responding variable, and so it's the one that responds. It's usually the data that you're taking. And then that is graphed on the y-axis. So it's graphed on the vertical axis. Okay. Then mix. M stands for manipulated variable, or the one that you change. That's the one that you change. That's the one that you determine. Okay. It's independent. It's the independent variable. It's independent of the experiment. So you're picking these values before you even do the experiment. You manipulated them and picked them before you did the experiment. They're independent of the experiment. And they are graphed on the horizontal or x-axis. Okay. So a little bit, again, here, the independent variable or manipulated is what you're testing. It goes on the x-axis. It's what causes things to change as you make changes to it. Some people nickname it the I do variable. Okay, this is the one that you are determining. It causes things to change. It does not change in the experiment. It causes the change in the experiment. Okay. The dependent variable or responding variable, that again is on it. It may or may not change as a result of changing the independent variable. So sometimes it doesn't change. Sometimes it just, there's nothing there's no change. Okay. And it's graphed on the y-axis. Okay, it's what you're observing. It's usually the data you're taking. We also talked about control variables. Control variables are not graphed, if you recall. Okay. They can affect the results of the experiment, but we're trying to keep the controls as consistent and the same throughout every experiment as possible. Okay. So you want to have as many control variables as you can when you do an experiment. The more the better. Okay. Some tips for making graphs. So these kind of apply to a larger variety of graphs, really. Okay, some just really simple tips here. Keep it simple. So be really concise, crisp, and clear. Don't add too many extras. Don't add like a million different things to it. Okay, you don't need to add a lot of different things. Okay. Graphs are meant to save users time in understanding data. So if there's too much stuff on the graph, it's going to take them a while to figure out what the graph is saying. Okay. The second thing, if you can plot multiple trials of data on one graph, do so. as long as it's not overwhelming. You don't want like 20 trials on one graph. Okay, you don't want like 20 lines on one graph, but if you have like 3 lines or 3 bars, 3 sets of bars, 3 trials, go ahead and put them on one graph. You don't need to put them all on 3 different graphs. I'd say like 3 to 4 is like max usually. 5 is getting a little cluttered. Okay, so as you do like more and more trials, it gets a little bit more and more cluttered. Make sure you label all axes with appropriate units, as well as give it a title. We're going to talk about title and axes in a little bit. Legends are not really necessary. They're not usually necessary in a graph. The only time they're necessary is if they're necessary. If you know what the data says without a legend, don't add it. Don't add a legend. Okay. Sometimes a legend is needed in something like a pie chart, right? In a pie chart, if there's like lots of different categories, then you might need a legend. But most of the time in a line graph or a bar graph, you don't need a legend. Okay, and legend is usually like a little key that'll tell you what things mean, right? What the colors stand for, or which trial is which. Most of the time, you don't need that. Okay, so let's look at parts of a graph and the types we're going to be looking at. So again, pie and circle, we're not going to talk about these today. Okay, maybe we'll deal with them another day, but not today. Bar graphs and line graphs are the ones that we use the most in science. Okay, and both of these bar and line graphs have an X and a Y axis. So that's why I'm kind of grouping them together today. They're very similar in the way we graph them and we use them. All right. The different parts of the graph that we have to point out here. The title summarizes information being represented in any graph. It's acceptable to say like the title can be like X versus Y. So like whatever your like response versus stimuli, or city versus time, dose versus response percentage, like if we're looking at these different graphs, so X versus Y. Okay. But typically, if you can, you want to write a title that tells us something new, tells us something different. Okay. I usually will put a title, for example, when we do this one down here, we're going to be looking at the deer population in a given location. Okay, so my data, or my table, my title will be something like deer population in wherever it was that we had looked at. Okay, and not number of deer per month. Okay, or number of deer versus month. Okay, or month versus number of deer, X versus Y. Okay, I usually like to include a title that tells us something new, tells us something different. Okay, tells us what we're trying to find. Okay, but again, it's acceptable to say X versus Y. Okay, when we look at scales for variables, so scales, we have to use a scale so that all data points are easily visible. The scale should be consistent, and the space between values must be proportional. So if you have 0 and 1 here, and 1 and 2, those are the same amount of quantity between 0 and 1 and 1 and 2. So the space between them should be equal. Okay, the space between them should be equal. Okay, you should also make sure that the scale is consistent. So meaning we go from 0 to 1, 1 to 2, 2 to 3, 3 to 4. So we're adding 1 each time. You don't want to go 0 to 1, then 1 to 3, then 3 to 7, then 7 to 8. You don't want it to be inconsistent. You want to be consistent. Okay. There is an exception to that. You can break the scale. Okay, I have some examples of breaking the scale here. So if there's like a large jump or a large difference between values and it can't all fit on the chart, you can break the scale. So here we have a bar graph that the scale is broken. So we're going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, and then we're breaking it all the way up to 32. So we show it, we have many different symbols that can show the breaking of a scale. So here's one of them, okay? And typically you're gonna write that break, if you're doing a bar graph, you're gonna do it in every bar that goes through that break. Okay. Now if you're doing a line or a scatter plot, this one here, this is a break. It goes from negative 110 to 100, and then all the way down to 10, and then 0, then 10. So these are 10 difference. These are 10 difference, but this one is like 90 difference. Okay, so the scale is not the same here. So it's another way to show it with a zigzag line, or like kind of like a squiggly line. And with a line or bar graph, you don't necessarily have to have the line or squiggly in the middle here. Okay. And this usually is used if there's like an outliers, or outliers that really don't fit the rest of the data, or you can't really fit it on the graph. You use the zigzag line or broken scale. Okay, and then the last example here, you can also do it this way too. Okay, most of the time I see it this way though. This is rare, but I guess I've seen it before like that. Okay, nothing too complicated here. Nothing too crazy. Okay, so let's look at this one right here. The following data, I'm going to do these two examples. And then I still want you to do these examples in your work. So I still want to see them in your work. So even though I'm going to do them, I still want to see you do them. Okay. Okay, so this one says, the following data was collected to monitor the deer population in a given location. Graph the following information on a bar graph. Label and number the X and Y axis appropriately. Oh, I also forgot to mention that you should include, did I say this? You need to include units. Where's that? Oh, maybe I didn't write that. I meant to do that. You need to include units on the side. Okay, so let's look at this data. Let's create a graph here. Okay, so typically you want to use a straight edge too. So I want to be doing this on my computer, and I don't think I have a line drawing thing with this. No, oh, I got a ruler. So you do want to use a ruler to create your lines if you can. So obviously I'm not like, I don't have this perfectly. I'm gonna try my best to do this perfectly, but we'll see. Okay, so here are y-axis, and then here is our x-axis. Oh, we can even do the ruler here. Oops. Okay, there we go. So we have our x and our y-axis. Let's put the ruler away. Okay, now we don't necessarily need a border around the graph. We don't always need borders. Sometimes people like to draw borders, but for example here, these two graphs, this one here and this one here, do not have borders. They look just fine to me. Okay, this one has a border, and it looks okay too, but you don't need a border. You don't need a border, so you can just leave it just like that. Okay, then dry mix. Okay, The dependent variable is on the y, so the dependent variable would be the number of deer. Oops. So number of deer. And that's pretty self-explanatory. The number of deer is just number of deer. Okay. If there was a units thing there, we'd use units, but in this case, there is no units. Okay. And then on the y-axis, sorry, on the x-axis, we have mix, the manipulated, or the independent variable that we are choosing ourselves, so that's going to be month. Okay, so next we need to figure out where all of our, or what all of our things are, our scale. So the month's pretty easy because it's just 1 month, right? September, October, November, December, January, February. They're all in order, so we can just have September, October. I really should have written month down further. I'm trying to do this in this small space here. And then next comes November, and then December, and January, and February. So I try my best to make the distance between them perfect. In reality, I should use this and make it perfect. If I really wanted to make it perfect, I could. So let's see, I could do there. Yeah, I should have used the ruler to make it perfect, but I did not. Okay, maybe we'll do that on the other side here. Okay, so number of deer, we go from the lowest number is 12 and the highest number is 38. Okay, so we need to find a scale that kind of fits those numbers. We can even use a bit of a broken scale at the bottom, and we can just start at 10. So I think I'll do that. So let's get rid of this ruler for a second here. So let's just make a broken scale here. Boop, boop, boop. And then here we'll start with 10. Because it's pointless to write all of it up to 10 if we don't have anything lower than 10. Or anything lower than 12, really. And then if we do maybe every 5, we have 10, 15, 20, 25, 30, 35, 40, 45. We could probably do that, or we could probably do 2. If we do 2, we have 10, 12. So I'm just counting here, 12, 14, 16, 18, 22. Yes, you can have multiple breaks. Yeah. 24, 26, 28, 30. Yeah, that's probably too many. So we're going to have to do it by 5s, I think. So do it by 5s. So let's use this little line right here. So we use that much, so about 2 ticks. So this and next one here. Oh, why is this word be weird? No, good enough. We'll just make those marks and then extend them over. Okay, put that ruler away. Okay. Okay, so we have 10, 15, 20, 25, 30, 35, 40. And we could actually probably stop there. So we could stop our graph right there, 40. Maybe go to 45, sure. Okay, so we have a consistent scale. Again, we have that break in the scale at the bottom. We have our dry mix, so dependent on the Y, the manipulated independent on the X. Okay, and now we can create our bars. Now again, you want to use a you do want to use a ruler. Okay, so I'm gonna use a piece of paper. You're not really gonna see me able to do it, but yeah. So let's see here. So let's start with September. In September we had 38. So now 38 isn't exactly on the graph, but we have to kind of estimate. We know that 35 in 30, so it's a little bit more than halfway. So it's probably right around here. Oops. So right around here. Okay, and then I'll make my bar. Okay, and then typically you're gonna make your bar so that the center of the bar lies on the center of this this line here. So we have the line there. You want to make it so that the bar is like centered on it. So I'm using like a piece of paper to make a straight line. Okay, so there's my bar for September. October is 32, so a little bit less than halfway between 30 and 35. It's about right there. There's my other bar. And then 26 in November, so right above 25. A little ugly there, but that's okay. And then 20, that's right on 20. So I'm using my paper to go across, like basically what I'm doing is this. I'm taking my paper and looking and it's like a ruler. I'm just taking the ruler and then I'm making my mark here. Okay, and then I'm flipping it this way. Oh, flipping it this way. To create a line here. And then right there, making a line here. And there you go. And then I'm not doing it on the top because I'm being lazy, but you should do it that way. Okay, and then 15, again, I'm taking my ruler, I'm not showing it right now because it's easier for me to just use a piece of paper. Bam, bam. Oh, that was kind of messy. And then 12. So that one I didn't use a ruler at all, but you should always use a ruler. Do as I say, not as I do, right? So there's our bar graph. You don't necessarily have to color in the bars. If you want to make it, if you want to do like little things, you can. If you want to leave it if you want to leave it blank, you can. Doesn't matter to me. If you want to color it, make it look pretty, that's cool too. Okay. Typically, I like it just black and white, really simple. We don't want to make it look fancy. It doesn't have to be pretty. Okay, just got to show the data. Okay. If you're doing multiple bars, like they have here and right here, this is great where they just use 3 different colors. And then you do kind of need a legend there, though. this would be considered a legend. It just shows you what the different things mean. Okay, so if you had multiple bar graphs, you do need different colors or different distinguishing factors. Okay. Okay. Now, line graphs or XY scatter graphs. So you might see it, line graphs, but really it's just an XY scatter graph. And then if it is a line, you can draw a line. So typically you'll see it labeled as this XY scatter. Okay. So here we go again. Let's do our lines here. And then this way. Put the ruler away. And then, so here we got to think, okay, dry mix, dependent on the Y. So the dependent, or the one that we're measuring during the experiment, is the number of bacteria. Oh, I forgot. What did I forget on the other one? What did I forget on this one? A title. Yeah, I forgot it. Why didn't you guys remind me? Forgot to do a title. So yes, every graph should have a title. Okay. Again, you could say deer versus, or month versus deer. I mean, you could say that, but that doesn't really tell us anything new. It doesn't give us any new information. So I like anything that's on the graph should give us something new or different information. We shouldn't have repeated information on a graph. Okay. We want the graph to be clear, concise, just very, very concise. So this should tell us something a little bit different. So we have deer versus month. Well, what are we looking at? We're looking at the population of deer. So deer population. And then I would say deer population in blank, wherever the location is. And the location. Let's just say location. Usually you're going to know where the location is, I hope. Okay, so that tells us a little bit something new. It tells us where we're taking this population data. And yes, we're looking at number of deer, but what does that represent? Well, it represents deer population. So deer population in blank, or in the location that we're looking at. It tells us something a little bit new. Different, something different. Okay, so bacteria, and then the independent variable, the one that we determine, we're taking measurements every day. Okay, every day. So number of days. Typically, so like I should have made one with something different. So here, I might change this for next period, but really you're going to be looking at, you're not like, the number of bacteria isn't necessarily where you're going to be looking at. You're going to be looking at the area. So the area of bacteria, area covered by bacteria. Okay, so let's just change that. Let's just say not number of bacteria, but area covered by bacteria. And we're going to use something like, let's say millimeters squared. So our units would be millimeters squared. So bacteria, area, and then the units will be millimeters squared. So you do want to include any units that are available to you with your data collection. Okay. So typically when we're going to be looking at bacteria like growing on a culture, so it'll be on a petri dish, and what they do is they have all the bacteria. You'll see the bacteria growing, and then it's usually broken down into broken down like this, and then they count the number of squares that the bacteria is located in, and it would tell you how much bacteria you have there. Okay, so if you're growing a bacteria culture, again, you put the bacteria on this petri dish. It's like a circle. The bacteria will grow. You'll see it, and then you'll put a little grid on top of it, and then you'll count the squares. However many squares the bacteria is in will be the area covered by the bacteria. Okay, typically in millimeters squared or centimeters squared, depending on how big your petri dish is. Millimeters squared or centimeters squared. Okay, so let's just assume this one is in millimeter. Yeah, it's probably centimeters squared. Whatever, it doesn't matter. Millimeters squared. But you do want to include units if you're given units. Okay. The next thing we got to do is create our scales here. So our scales. So this is just 6 days. Yeah. Like I said, they didn't give the units here. I'm just saying that they're just saying number of bacteria. That doesn't really make sense. So I should have changed this. I should have made this area covered by bacteria. Okay, so I'm changing it now. It wasn't given. I'm changing it to area covered by bacteria and saying the units are millimeters squared. Okay, so they didn't originally give it. I'm giving it now. I'm changing it to show an example of what the units would be. Okay, and you include the units in parentheses next to or underneath the axes title. Does that make sense, Yenhan? Okay. Yeah. Sorry if I confused you there. Okay. Okay, so we just have 6 days we got to put here. So we can space it out a little bit more down here. So let's see. Let's do this. One here. One here. So 1, 2. Let's see. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. That's 1, 2, 3, 4, 5, 6. Yeah, we can even space it out even more. So let's get rid of some of these. Oh no, that's not what I want to do. I'll just keep making the marks and then I'll just do it. Oh, I'll do it every other one. So I'm just making marks, making sure that I'm making them the distance between them is the same. And I'm just going to do it every 2. 1, 1, 1, 1. So this will be 1, 2, 3, 4, 5, and 6. Okay. Okay, now this scale is a little bit tough. I have 4, 16, 40, 80, 100, 200. This is a tough one, right? Let's space it out first, see how much. Let's get this going here. Let's do Did that right? Okay, so we have a line here, here, 2, 3, 4, 5, 6, 7, 8. Okay, we're definitely going to need a broken scale here, right? Let's see. This one's a really tough one. Let's do 20. Let's do 20. Maybe that even will work. 20, 40, 60, 80, 100, 120, 140, and then let's do a broken scale up here to 200. Okay. Now this is we try and keep. I mean, it doesn't have to stay the same because that's exactly what's happening when we break the scale. Is we're changing the pattern of numbers. That's exactly what's happening when we break the scale. We're actually changing the pattern. We try and keep the pattern as consistent as possible until we get to a break in the scale. Does that answer your question? Okay. All right. So it's a little bit tricky, and this is 0 here. 0. So on day 1 there's 4. So I'd say like that's 10, right? So a little bit less than halfway. So it's like all the way down here. 4. And then 2 is 16. So somewhere a little bit pretty close to 20. And then day 3 is 40. So that's an easy one. Again, you do kind of want to take your ruler and find exactly, if you can do it exactly, do it exactly. So that's 40 right there. And then 80, so 80. And then 100. And then 200. Okay, now typically, like in a graph like this, you really want to avoid breaking the scale because it's really going to screw up the trend. In a line graph, we're typically looking for a trend, right? And this is going to be an exponential growth. That's how bacteria grows, and we kind of want to see that. So really, I probably shouldn't break the scale here. I should keep. Let's try and make it the scale consistent. So we'll just continue it up here a little bit. 140, 160, 180, 200. Now, of course, you should do it a little more neatly than I do, but do as I say, not as I do. So I got rid of the broken scale because now you see a little bit better of a pattern here. Okay, if you look, you get an exponential growth. It's much more clear than if you had that broken scale. Okay. And then last thing we need is a title. So this would be usually, like for this one, you'd probably tell me the name of the bacteria. So whatever bacteria growth. Okay. So let's see if we can change this. Let's change this. Let's add something here for C. Your units are going to be percent. So when you do this and you write grade here, you should write in parentheses percent. And then enzyme activity. I don't even know what they measure enzyme activity in. Let me see if I can find a unit there to include. Anyway, let's just keep it that way. Just remember that when you do, if there are units, you include that. Yeah, I don't know. Okay, so yeah, your job is to make sure you create those two graphs that I created already. You can do those on your own, or hopefully maybe you're doing them while I was doing them. And then just do C and D. Okay, take a picture and turn it in. Any questions? No? Okay. That is all I have to say about that then. I'll see you guys tomorrow unless you have any questions.